Hello guys, welcome back to Aapka RPS. This is the new video of AI project cycle, that is the second chapter of your syllabus. In this video, we will cover the fourth stage of AI project cycle, that is modeling. In modeling, we will see different type of learning approaches and the subtopic of those learning approaches. In this video, we will also cover several examples of those learning approaches and subparts. Without being late, let us start our video. But before starting video, do not forget to subscribe our channel. So guys, here is our slide of modeling, that is the fourth stage of AI project cycle. What is modeling? AI modeling refers to developing algorithms, also called models, which can be trained to get intelligent outputs. That is, writing code to make a machine artificially intelligent. Now, AI modeling basically refers to creating algorithms, to developing algorithms, and those models which we are going to create, or not models, the machines which we are going to create are known as models. If I make it clear to you more deeply, then not the machine, the algorithms which are fed in that machine are models, not the complete machine, which can be trained to get intelligent output. That is, by writing the codes by developer and make it artificial intelligence by training them through those codes. Graphically representation makes the data understandable for humans, as we can discover trends and patterns out of it. So every human can do understanding process through graphical representation. We can easily analyze the graphs, and we can easily get the data what that graph is trying to say. Now this task is very complex in machines. How the machine do? When it comes to machine accessing and analyzing data, it needs the data in the most basic forms of numbers. So machine cannot understand your graphs. Machine only understand what? Binary language, that is 0 and 1. So machines need each and every smaller detail in that language, their natural language. And when it comes to discovering patterns and trends in data, the machine goes for mathematical representation of same. If a human is looking our graph, it can easily analyze through their mind, but the machine needs so long mathematical representation to understand it. The ability to mathematically describe the relationship between parameters is heart of every AI model. Thus, whenever we talk about developing AI model, it is the mathematical approach to word analyze data which we refers to. Here we divide AI models into two parts and one subpart into more two parts. Let us see. The AI model is here. This AI model is divided into two parts, learning based and rule based. Rule based is not further divided, but learning based is further divided into two parts, that is machine learning and deep learning. Let us understand about rule and learning based approach or models. So rule based refers to AI modeling where the relationship or patterns in data are defined by the developer. So if I am giving any data to the machine, then what I am supposed to do? I am supposed to give the whole relationship and patterns of the data, not whole, the complete relationship and patterns of the data, so that machine can understand each and everything through my provided data. The machine follows the rules and instruction mentioned by the developer and perform its task accordingly. Now, here if I have programmed you have to take one glass of water to the every customer which are coming in the hotel or restaurant, then machine will not provide anything else till I am instructing it, or till I have instructed it in the course. It will simply serve only one glass of water. That is rule based. But when we come to learning based, refers to AI modeling where the machine learns it by itself. Now I have not tell the machine that you have to serve a glass of water, but machine is serving how? The machine is learning that thing. Simple. Just I have told in my explanation that I have not given the information to the machine that it has to serve a glass of water. But the machine is serving the glass of water. How? That is learning based. Now in my explanation, I have just told that the machine has not got the code of that you have to serve a glass of water. The same thing is our second point, that in this the relationship or pattern in the data are not defined by the developer. In this approach, random data is fed to the machine and it is left to on the machine to figure out patterns and trends out of it. I will give you a small example in our next slides of a learning based approach or a rule based approach. Let us look first these points. Generally, this approach is followed when the data is unlabeled and too random for a human to make sense out of it. Now, we humans have a little bit difficulties when the data is so large. Now, who will do this in less time? Because if data is very large, humans take too much time and the time is so expensive. The machine used to do these things quickly, and that's why we have created learning based approach, so that machine can take out the pattern and relationship out of it. Thus machine look at the data, tries to extract similar features out of it and clusters same data set together, just I have told you. In the end, as output, machine tell us about the trends which is observed in the training data. Now, rule-based approach have a point, that is decision tree. This is the example of rule-based. Decision tree is the most powerful popular tool for classification and prediction. A decision tree is a flowchart-like structure where each internal node denotes a test on an attribute, each branch represents the outcomes of the test, and each node holds a class label. Let us see a graph now. Here first this is the root node, then this one is the internal node, and the last is leaf nodes. Let us understand how we classify these internal nodes, root nodes and leaf nodes. So if you can see that on the arrows are coming from this box, right? Arrows are only coming out. So when you see a node that from where only arrows are coming out, that will be the root node or root. Now how you will find internal node? Here you can see one more arrows are going on. Yeah, one this and one this. Now this is the identity of leaf node. Only the arrows are going inside it. That is a leaf node. Same here. Only arrows are going inside, no coming out. But in internal node, arrows will come in and also arrows will go out. That is internal node. Let's move forward. Now here you can see an example. You can see here is outlook, then temperature, then humidity, wind, elephant spotted. So what we are trying to do is we have four main factors: outlook, temperature, humidity and wind. We denote these factors as data features, if you remember my last video. So these are data features, and from these four we are trying to get the knowledge whether elephant will be spotted or not. Let us see. If outlook is sunny, temperature is hot, humidity is high and wind is weak, elephant is not spotted. Again, sunny outlook, hot temperature, then high humidity, strong wind, still no elephant. Overcast outlook, hot temperature, high humidity, weak wind, elephant is spotted. Same, rain, mild temperature, high humidity, weak wind, elephant spotted. Again, outlook is rain, temperature is cool, humidity is normal, also wind is weak, elephant is again spotted. If we move forward, there is a rain outlook, cool temperature, normal humidity, strong wind, but no elephant. Then when we see overcast with cool temperature, normal humidity and strong wind, elephant is spotted. How many factors we have worried? 1, 2, 3, 4, 5, 6, 7 are there. Now here are more: 8, 9, 10, 11, 12, 13, 14. So total we have 14 parts. Now let us read out them also. Sunny outlook, mild temperature,
high humidity, weak wind, no elephant. Here sunny outlook, cool temperature, normal humidity, weak wind, elephant is spotted. Rain outlook, mild temperature, normal humidity, weak wind, elephant spotted again. Sunny outlook, temperature is mild, humidity is normal, and strong winds are going on, elephant has again spotted. When there is overcast with mild temperature and high humidity, also there is a strong winds are blowing, elephant has again spotted. If overcast is there with a hot temperature, normal humidity, weak wind, elephant is again spotted. Then rain outlook, mild temperature, high humidity, strong wind, no elephant. We have read all 14. Let us know how the machine will react to this data. First of all, let us take a example. Let us take overcast. Two overcasts are there. One, two are there. So first of all, machine will classify each outlook. Okay, like these are three rain, these two sun, then overcast. Machine also can do what? Can classify through the cool temperature, mild temperature, hot temperature. But here we are classifying through this. So let us take the overcast first of all. So there are four overcast. Our table will look like this. The four overcast are here. You can see. Yeah, these are overcast. You have seen. So here, when the temperature is hot, humidity is high, wind is weak, elephant is spotted. This is the training data actually. Cool temperature, normal humidity, strong wind, elephant again spotted. Now mild temperature, high humidity, then strong wind, elephant again spotted. Hot temperature, humidity normal, weak wind, elephant again spotted. Now the machine will try to make relation. There are not same temperature. Okay. So if we see overcast, in overcast we cannot take temperature as a factor of division whether elephant will spot or not. Then again humidity, there is normal, high both. So we cannot take humidity as a factor. When we see wind, there is weak, strong, then again strong, then again weak. So wind is not the factor. Now the outlook. If you see outlook, the four patterns are overcast, and in all the overcast, answer is yes. So what the machine will find, or what the machine will summarize that if the outlook is overcast, answer is yes. So when overcast, answer is always going to yes. This is the summary. Now we have taken the rain. When there is rain with mild temperature, high humidity, weak wind, answer is yes. When there is rain with cool temperature, normal humidity, weak wind, answer is again yes. With rain of cool temperature, normal humidity, strong wind, no answer. Rain with mild temperature, normal humidity, weak wind, answer is yes. Rain with mild temperature, high humidity, strong wind, answer is again no. So if you see, in each case there is rain, but there is also a problem. What? Here if you see there is three yes and two are no. So it cannot be a factor to measure. Now let us see temperature. Can temperature be a factor? If mild, there is mild yes. If cool, yes. Again cool, no. Here is also mild, no. This yes. So you can see if there will be a pattern, then if we choose the temperature is the right answer, then there should be like all cool are no and all milds are yes, then it will be a factor. But here the answer is no. The machine will simply deny the temperature factor. Now it will take humidity. High humidity yes, normal humidity yes, but here normal no. Here high is also no, and this normal is yes. Same reason which was for temperature, that's why humidity is also cancelled. Now the last factor is wind. Can we find a factor from this? Can we find a pattern from this? If weak yes, again weak yes, strong no, sorry, then weak yes and strong no. Now you can see here is a factor. In when the wind is strong, always no is shown. So wind is the factor. In rain it will take wind as factor, and here what is there? Wind will be divided into two parts, weak and strong. When strong, answer will be no. When weak, answer will be yes. So now the chart will look like this for my machine. Overcast, answer yes. When rain, the factor is wind. Because here the factor was overcast, so no node between it is available. This wind. Now wind is simply divided into what? Two parts. How many parts? Two parts. Weak and strong. When weak, answer is what? Yes. The answer which we have find. And strong, no answer. So here you can get an idea. Now sunny, the last factor which the machine has to analyze. Here first of all it will see here no, 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 yes, yes. So yes and no both are there. It will simply deny the outlook factor that always sunny will not give a fixed answer. Now it will look on a temperature. Hot no, but mild is also no. Temperature is also denied. Humidity high no, high no. Here also high no, but in both normals there are yes. It will simply accept the humidity as a factor. Now the chart will look like this. If sunny, we will take humidity as a factor. So what are those factors? Normal and high. And see here, yeah. Then if high, answer no. If normal, answer yes. Now let me remember you what are root nodes and what are leaf nodes. The node from where always arrow comes out is root node. So the outlook one is root node. Then you can see the sunny and overcast and rain node arrow is coming out and coming in. So these are what internal nodes. Let me take on the internal nodes. Okay, so these are internal nodes. In humidity you can see arrow is coming out and coming in. It is also internal node. High is also internal node. Normal is also internal node. If we see this wind, strong and weak, these are internal nodes. And this one, this yes, this one node, this one and these two, these are what? These are leaf nodes because only arrow is coming in. So we have completed the rule based approach. Now let us understand learning based approach. Some common AI models are learning based approach is basically divided into three parts that are supervised, unsupervised and reinforcement. Okay, let us see about this supervised learning algorithm. Basically, in a supervised learning algorithm model, the dataset which is fed to the machine is labeled. In other words, we can say that the dataset is known to the person who is training the machine. Only then she is able to label the data. So in unsupervised learning, the dataset that is fed in the machine is labeled. In other words, we can say that the dataset that we have were given for training is known to a person, and he or she has labeled that data so that machine can understand. The label is an information which can be used as a tag for a data. For here this one is apple, simple data is given. For mango here we have labeled, orange is also labeled, then watermelon is also labeled, that is labeled data. Now unsupervised data. An unsupervised learning model works on unlabeled data set, so it doesn't require labeled data set, it works totally on unlabeled data set. This means the data which is fed to the machine is random, and there is a possibility that a person who is training the model does not have any information regarding it. So if you see that example, this one example, there can be a person who does not know the right name. Yes, it seems like funny, but it is just for example that a person does not know that this is an apple. Then what the person will do, it will take help of learn unsupervised learning algorithm so that machine self can classify those. The unsupervised learning model are used to identify relationship patterns and trends of the data which is fed into it. It helps the user to understanding what the data is about and what are the major features identified by the machine in it. So this is the input by our user. That's why he or she use unsupervised learning algorithm, because they does not have understanding what the thing is. Now what will unsupervised learning algorithm do? It will simply take one by one each data set or each element. Simply it will take this apple. We know that this is an apple, but machine does not know. Now it will scan it, finds the feature and will try to match from these things. Now these two are also same. So now what will it do? It will simply classify this. Now it will take second element and classify the mangoes, then again the watermelons. Okay, one by one it will classify it. Now what is reinforcement learning? Reinforcement learning or RL is an area of machine learning concerned with how software agent ought to take action is an environment in order to maximize some notion of cumulative reward. Reinforcement learning is one of three basic machine learning paradigms alongside supervised learning algorithms and unsupervised learning algorithms. In reinforcement learning, the machine is not given example of correct input output pairs, but a method is provided to the machine to measure its performance in the form of reward. Reinforcement learning method resemble how human and animals learn. The machine carries out numerous activities and get rewards whenever it does something well. So reinforcement learning is just like the human's child's understand. Basically, if a person remembers when he or she was in first or second class, ma'am would give a star or a good on the notebook. From those star and goods, you understand that yes, I have done a very good work. But at the same place, when the teachers write poor, the feeling of that poor came into your mind that yes, I have not done the good work. That is the reward of your work. Just according to that, machines also understand it. For example, when you rate anything, 5 star means good, very good, and 1 star means poor. Just through that formula, machines also understand how I have to react or how I have to reconstruct our method, his or her methods to do work, so that the customer or the user which was using me can satisfy from my work. So if you are new on our car, please do not forget to subscribe our channel so that you can get the new videos notification quickly.
Thank you guys for watching the complete video. I hope you have understood all the topics in this video, and if you have any doubt, do not hesitate to give a comment in the comment box so that I can answer you quickly, and do not forget to subscribe our channel and like the video.